Hello everyone. Reaction of alcohol with SOCl2 with mechanism. In previous videos we have understood mechanism of reaction with alcohol with PCl3 and PCl5 and their mechanism. Now next and last SOCl2. In SOCl2 the condition is this. Now sulfur electronegativity is less than both chlorine as well as oxygen. So electrons are getting shifted toward them. So sulfur is getting positive charge. Alcohol is there in which we know oxygen is carrying a negative charge due to very high electronegativity. That's it. It is going to attack on sulfur. Now sulfur is making 4 bonds. So obviously, first of all, out of 4, one bond will break. Here sigma and pi bonds are available. So between sigma and pi bonds are weak bonds. They break always if we compare sigma and pi. And how this pi bond will break? Oxygen is more electronegative than sulfur, so both electrons will shift toward oxygen atom. Due to which this oxygen will adopt, because this electron is of sulfur and oxygen is gaining it, so oxygen will adopt a negative charge, -1 charge. Cl is as it is, Cl is as it is, and oxygen is going to make bond with sulfur. Now oxygen is making 3 bonds. Out of 2 pairs, it have used 1 pair to make bond with sulfur because sulfur don't have electron for bond formation. Those electrons are gone toward oxygen. So for bond formation, 2 electrons are required which will be delivered by oxygen. Means this bond is coordinate bond, dative bond. Now when oxygen is giving one of its electron to sulfur for dative bond formation, this oxygen will carry a positive charge. In this condition, what will happen? Oxygen will try to stabilize itself. How? By breaking bond from hydrogen side, and we will have this one, and H positive ion will release out from here. And this oxygen will stabilize. This is H positive and this is Cl negative. So HCl product will be generated over there. And this oxygen will bring back these electrons here. And chlorine will break bond from sulfur like this. And we will have SOCl, O, R, and HCl. But in previous video I also told you HCl is a strong acid, will break out H positive and Cl negative. Now R is carrying a positive charge. Oxygen is more electronegative than R. So this Cl negative will attack from back side of R, which we call SN2 mechanism. In previous videos I also told you when PCl3 and PCl5 was reacting. So this Cl negative always attack from SN2 mechanism on R group. In this condition, between R and O bond will break and both electrons will shift toward oxygen because oxygen is more electronegative than R. So this molecule will turns to SOCl and oxygen is carrying extra electron, so oxygen will have a negative charge over there which will be balanced by H positive. This molecule will turns to Cl, S, O, OH, and RCl from here will generate out. Like this. Now again, what about this molecule? This molecule finally will make itself better because chlorine is more electronegative than sulfur. Chlorine have a negative charge, hydrogen have a positive charge. Positive negative interaction will be there and bonds will break again. So when oxygen and hydrogen bond break, electrons will shift toward oxygen. Between sulfur and chlorine bond will break, the electrons will shift toward chlorine. So when bond will break, sulfur will have a vacant orbital and oxygen will have an extra lone pair that I am drawing. Cl will release out as Cl negative, H will release out as H positive, and HCl will generate out over here. And this will become SO with a vacant orbital on sulfur carrying +1 charge, oxygen carrying extra electron carrying a negative charge, because one electron was gone with chlorine, so sulfur have a +1 charge with a vacant orbital. Now how they can stabilize each other? This is a vacant orbital, this is a fully filled orbital. They can make bond with each other. And finally, this will release out sulfur dioxide gas, SO2. Here we have HCl, here we have sulfur dioxide gas, and here we have the main product that we want, RCl. So this is the mechanism that we have when alcohol reacts with SOCl2 to create RCl, SO2 and HCl. Out of three methods of preparation of chloroalkane, there we have three methods: ROH plus PCl3, this method we can use; ROH plus PCl5, this method we can use; ROH plus SOCl2, this method we can use. The preferred method is ROH plus SOCl2. The reason is side products are gas. HCl will generate out in the form of gas. Sulfur dioxide will generate out in the form of gas. So they will leave reaction mixture by their own, and we will left with our main product RCl. So that's why, but in the case of a PCl3, PCl5, they are not leaving the reaction mixture. They will present there. So first we need to separate out RCl from those side products. But in this third case, automatically side products are getting separated in the form of gas. They are leaving reaction mixture, and we will have a pure RCl with us. So these are the mechanisms for PCl3, PCl5 and SOCl2. Thank you very much for watching.